Okay, thank you very much. And let me start the seminar this time. So welcome to the crowd-science seminar. These seminars cover a broad area of human-AI collaboration to allow discussing past and future work, exchanging ideas, and establishing new collaborations. Clustering is a useful machine learning technique to discover structure in data, to perform exploratory analysis of the data, and so on. However, it requires knowing the distance matrix between the objects, and sometimes it's very difficult, sometimes it's intractable to obtain computationally. So this seminar, Professor Sujoy Chatterjee from the University of Petroleum and Energy Studies, India, will talk about decision-making from crowd clustering. I'm really happy to give the stage to the speaker.
Thank you so much. Thank you for this invitation. Yeah.
Thank you.
Sorry, yeah, thank you.
Yeah. Can I start now?
Yes, please.
Yeah, okay. So, good evening, everyone. The topic of, the title of my talk is decision making from crowdsourced clustering. So basically, I'll be starting some basic things because decision making. First, I will discuss that what is the decision making from crowdsourced opinions, and then I will come to that part that how I can aggregate the decision from different crowdsourced opinion and then crowdsourced clustering. So first of all, I need to discuss something on little bit on this crowdsourcing part, that how I can do crowdsourcing to manage different difficult tasks that is not achievable by simple machine or computers. So here, if I see, suppose for example, can just okay, so we are all familiar with this Captcha and reCAPTCHA. We are all familiar with, every day we type this Captcha and reCAPTCHA, and for filling up some form, every day maybe that's 3 tries or 4 times we can type that. And this basically, I'm talking this because there is an interrelation between this decision making and judgment analysis. So decision making from crowdsourced opinions. So before that, actually we are doing some kind of judgment. We are trying to get some opinion from crowd in different way, and then we are trying to find some quality analysis. We are trying to find some consensus, some aggregated opinions, so that we can remove some spammers. Okay, I will discuss this some important terms that I discussed. That first, if I see, suppose is in Captcha or reCAPTCHA, you know that it's like we are typing some distorted characters. So here, basically, there is a when we are typing these things, basically computers understand that we are the human beings who is typing this form, not an that we the entity are the human beings who is typing this form, who is that basically gives them that, yeah, this is not an bot, robot or something like that. So that's why they validates this thing, that whether this information this user is typing and what is given in that captcha, is it right, is it matching or not. But the thing is that here, when we are typing this captcha, it is seen, there is a great statistics that roughly every day it is seen that 200 million captchas are typed, and for each captcha it takes 10 seconds. So 10 seconds for each captcha. So in general, it is seen that we are wasting at about 500,000 hours. So it's a huge effort that we are wasting every day just for typing this captcha. So one scientist that Louis von Ahn, he basically developed these things that if can we utilize this vast human resources for this humankind. So basically, when we are typing this captcha in background, actually we are doing something great. We are doing something great that computers can't perform. So that's the important thing. Because you see, when we are typing this captcha, we are typing some distorted text, and this distorted text are basically coming from some old books that are going to be digitized. So there are a lot of books available in, different libraries, and there are millions of books like that. And these books are needed to be digitized. But the problem is that there is an optical character recognition tool. There is a tool that is available in market. But the problem of that tool, that first what we'll do, we'll scan this page of that book, each page, and then something optical character recognition will recognize that character. Some text are basically those books are all, very old and yellow colored pages. Those are distorted. So it's basically very difficult to get the recognition. I mean, that if I know that, yeah, something like that A for this M or A, it is going to be distorted. Okay, so if it is very old, if it is yellow colored, it comes from this yellow colored pages. So in that case, it is very difficult for OCR to recognize this character. So machine can't solve this problem, and it is seen that about 70% case that OCR can solve this problem, can recognize this, but the rest of the 30% is not solvable by this machine. So when we are typing this captcha, we are basically knowingly or unknowingly, okay, we don't know that we are solving a great problem. So knowingly or unknowingly, we are solving some kind of problem. That is, we are typing some, we are helping to digitize some books. That is going to be, there are a lot of books over there, and we are helping this. So in this way, basically, we are helping for, we are doing something for mankind actually, but without taking any money. I mean, people can't take that, they don't get any remuneration to type this captcha and to solve this digitization problem. Right. So this is the, this is the background story of this crowdsourcing, that, yeah, if I have a large task and if I can decompose this task, and if I outsource this problem utilizing the vast human resources, that is in crowd, that local general people, and if I get the opinion from them, then that problem can be solved very easily. But there are so many challenges. So there are many applications where that crowdsourcing can be used to solve different real life problems. For example, in crisis management, that in crisis management, people are scattered there, and it is very difficult to get that where from this actual crisis happened. So that's why if everyone posts from their location, that, yeah, if everyone is searching and he gets some information from his neighbor. So if this kind of things happen, then it will be very much easier to get that information, that what is the actual source of that problem. So something that, for example, Malaysian Airlines, what in that case, while it got disappeared in that time, it was very difficult to search that exact place where it got, in which place it got disappeared. So basically, they outsource this problem in such a way that people are collecting the wreckage of this flight, and they are matching those things, that whether these images are equal, the same or not. So somehow they have accumulated many wreckages, and image matching was there, and then finally they got the source, that where in which place that accident occurred. So there are many applications even in health science nowadays, like PLM, that is patient like me. PLM is an application. So to solve this health related problem, utilizing these vast human resources, just here basically that PLM is like patient like me. If you have some disease, then you can outsource this problem to that crowd, that I have that same symptom. Then how I can get out of that. So basically, other patients will give their response that, yes, for this chronic disease, you should do this kind of things. Okay, fine. There are some problems because there are some spammers. There can be some spammers who can malfunction this whole thing. So quality assurance is the biggest challenge for this. So right now, if suppose someone has some questions, like suppose I have a question, I am putting this question in, I don't know the answer. So that's why I can put this question over the internet, that showing my son Disney Aladdin, make him to join ISIS, will it? So he doesn't know this answer. So something he can outsource this problem to this big crowd and he get the opinion. And now the question comes that how I will, if there are three options like yes, no, skip. So the question is how I can aggregate those opinions to get the final answer. What should be the final judgment? So from here I can make some decisions. So basically in this case, there are something like yes, no, skip, some discrete opinions are there. You have some predefined opinion option set like yes, no, skip. Now, in this context, I can tell that yes, this if I have some questions, I want to solve this question, I can outsource this question to crowd. So in that case, if these questions, these are suppose this is a response matrix which contains the response of this crowd worker for different questions. So in this case, you see that for you there are 4 questions and 5 workers, and the options are like yes, no, I can't tell, unsure, skip. So right now, what I can do, if I want to make some decisions that yes, I got for question 1, I got 4 answers like yes, no, yes, and I can't tell. So what will be my final answer? What should be the aggregated answer for that? So the simplest approach will be that, okay, I can do majority voting, and this majority voting can give you the final answer. So in this case, yes can be the final answer. Fine. But the problem here that if I treat that, if I apply this majority voting, in that case, it means that every worker is treated as equal expert. That means you are treating this, this as same or equal expert. But in real life, it may not happen. Sometimes it happens that yes, this annotator 1 is basically a spammer. He wants to give some random answer without knowing that correct answer, and he can put that options. So that's the great problem, and this is the biggest challenge, that how I can rectify those things, how I can remove those crowd worker to find the final answer, to get the good quality. So now to obtain this final answer, there are many methods. So now it is available over there. First, we can do weighted majority voting, because weight can be defined based on their expertise. But the thing is that here, for example, this question, if I come to that judgment matrix to make some decision, because we are talking about the decision making from crowdsourced clustering, but right now I'll talk that decision making from crowdsourced opinion. So here, basically, if there are 5 options like yes, no, skip, I can't tell, unsure. So in that case, you have this judgment matrix which column wise, there are some options like these 5 options, and there are 5 questions. Suppose here 4 questions, I can put different questions here. So here you see this gives some weighted version of this question, particular Q1. I can tell that yes, O2 is the final answer because that weight is maximum, and those weights are basically calculated from this. We have some metric. We can define some metric by which we can get the weight of these different annotators. And then finally, I can get that what should be the weighted voting weight of this particular option for that particular question Q1. So for each option like O1, O2, O3, O4, O5, I can get some weighted voting. And finally, that value which is maximum can be treated as the final answer. So that is the context that how I can do, what can be the approach to find that final decision from this judgment matrix. So now, if I can see the problem formulation, so in simple case, not considering the clustering part right now, just for simple case, I can tell that if I have a multiple question Q1 to Qn, and if I have a set of annotators A1 to AN and set of options. So here, please note that these option sets are predefined. I know that what can be the answer. Maybe it will be from yes to no, or yes, no, unsure, I can't tell. So these are defined over here. And there will be a mapping function like Q cross A implies O. So basically that means that when a particular annotator responds, gives his response for a particular question. So basically this mapping will be done. And here it is not mandatory that all the worker will give the response for all the questions. So it is not mandatory. So that's why it can be some sparse matrix. So this response matrix can be sparse. So now, when we define this response matrix, so you see this is our response matrix R. Basically, it is n cross m, where n be the number of annotators and m be the number of questions. And the judgment matrix is basically m cross k, where k be the number of options and m be the number of questions, right? So m cross k, judgment matrix. And finally, we want to find the answer decision from these multiple options. So now there are some, I mean, just a minute, I'll wait. Maybe it will be better.
And you have
Yeah.
a gray bar at the bottom of your screen that maybe some panel of some application. Yeah, so is it possible to remove it?
Okay, no. Okay, so I think that it will take some time, maybe. So anyway.
Okay.
Anyway, yeah. I want to show that, yeah, this is the response matrix, and you see here, there are some crowd workers and annotators are used synonymously, and there are some questions. So as this is a sparse matrix, so I can group those workers and questions simultaneously. So it's like that clustering. We are doing some kind of bi-clustering over there, so that we can see that which type of worker is associated with which type of questions. Maybe some workers will be attempting some similar type of questions. So we want to segregate those crowd workers to find that association, that which kind of worker is associated with which kind of question. And based on this, we can get some judgment. I mean, that from this bi-clustering, actually, this is the bi-cluster from this, these are the bi-cluster, and where basically is for certain type of questions, those crowd workers are attempting, and for rest of this question, similar type of crowd workers are attempting. So now the question is, there can be some overlapping of it. I mean, that some overlapping bi-cluster can happen. So in that case, how we can do the judgment, we can discuss. But for this time being, I will not go in deeper into this, because I am much more interested on different techniques, that how I can utilize this crowdsourced opinion and how I can outsource this problem. So here, basically, that questions are like, we know that options, and these opinions are collected independently. Each worker is not dependent on other worker. He cannot see the other's opinions before posting his own opinion. So this is the independent set of opinions given by this crowd worker. So right now, I will try to discuss another thing. So that is that first it was independent crowd worker. Independently, they are giving their opinion. But I will try to show something that is dependent crowd judgment. So here we introduce something that, suppose I have, in many cases, you see that when we are trying to buy something, we use that online shopping, and in that case, so many reviews are available. And when a new customer wants to buy something, then in that case, he generally wants to see the review. And after getting this review, he decides that whether he will purchase or not. But the thing is that whenever you will see these things, these reviews over there, he can be biased. He can be biased to buy this product. But the thing is that there may be, although it is seen that for Flipkart, okay, so in that case, maybe there are some reviews, but it may happen that someone has not used, or intentionally, someone has not used this product, or intentionally he put some wrong or bad opinion, bad reviews over there to do some kind of malfunctioning. Maybe some in competitive environment, some other business man, he can try to beat these things. So he can put some anonymous, there are some bad comments on this product. So that will be very difficult for a new customer to judge. So whenever you see that for Flipkart, they give some kind of rating, aggregated rating from there, but they have their own policies. But right now, in case of crowdsourcing, we are assuming in first case, it is seen that, yeah, in first case, we are seeing that there are some algorithms like probabilistic graphical model or some algorithms where we can see that some hidden features are there, hidden attributes are there. So we need to estimate these things. But every time it is considered that opinions are given independently. But in real life, it may not happen. So that's why when the crowd worker is giving their opinion, we are assuming that they are independent, they don't know other answer. But right now we are seeing that yes, in online shopping like this, we can check that dependent opinion also. So we developed some methods that how we can utilize this model, one dependent judgment model, where from that dependent decisions we can take the decisions from crowd workers in dependent way. So there are some problems. I'll tell you there are some problems, but it will be another technique by which I can get that exact crowd opinion. Maybe in previous case when they are giving some independent crowd opinion, in that case there may be some bias, there can be some other malfunctioning, but I can retrieve it in a better way if I take the opinion from this crowd worker in two-phase manner. So what is the model in that case? And that can be useful also in our crowd clustering context. So here, first, what I can do, first suppose we have some questions and we can outsource this question to different crowd workers. And in that point, basically, they don't know each other. They don't know that what other persons are giving. So in that case, it is considered as independent crowd opinion. Then after getting their independent opinion, we are disclosing all this opinion to this crowd worker. But we are not giving that you have given this, you have given this person is giving this response, other person is giving this response. We are just giving some statistics or some kind of distribution that yes, if there are three options like 1, 2, 3, we are giving that yes, 50% is saying 1, 20% is saying 2, and 30% is saying 3. So then we ask this crowd worker that whether you want to change your opinion or not. So right now this question comes that yes, if he is not confident in his own opinion, so he may deviate after seeing others' opinion that yes, majority people are saying that 50% majority people are saying 1, and I told that yes 3, so I can change their opinion. So I can change my opinion. So in that case, he can deviate himself. So in that way, we can get that whether this crowd worker is confident or not. So there can be some metrics that confidence, reliability. I will not go in detail on that, but I will showing some examples that yes, I have currently 2 sets of opinion like independent score and dependent score. Some worker may change their opinion, some worker may be overconfident, or he may be really confident. So he can change his opinion after seeing others' opinion. So our objective is to find that how I can calculate that decision from this final, these 2 sets of score. 2 sets of code means that independent opinion and this dependent opinion. So we developed something. Look, suppose this was helpful for case study. Suppose we know that review paper in different conferences that a lot of papers are being submitted, but here basically we do some kind of things like we review, we communicate with those reviewers and then get their response. But the problem is that in that case, it is going to be very time consuming. But right now, nowadays, if crowdsourcing is used for the paper review, like F1000 research, and in that case, we can utilize this concept that whether if we take 2-phase opinion from them and then we can outsource, we can get some judgment using some technique that whether his transition is effective or not, whether this transition he is going accept to reject. From accept to reject, he is trying to give some opinion, but it's not. We need to find that which should be the effective answers. So right now I'll skip this part because we have taken some time for different opinion collection. But right now I'll come to that point that in presence of this crowdsourced clustering, clustering is a very important thing, but image clustering is very difficult in some kind of problems like hard image clustering tasks, where basically the images are ambiguous and very difficult to understand for machine. That what should be the what should be the particular cluster. So it is very difficult to understand. So that's why clustering ensemble can be used by utilizing this power of crowd. So there can be some hard image clustering tasks that cannot be easily solved by computer, and that can be accomplished very easily if we can outsource this problem to crowd. So here some methods are developed, but there are some drawbacks. Like for example, we can instead of I have suppose 500 images, so I cannot outsource all these images because there can be some similar images. So in that case, we can do some kind of age query. We can do some kind of age query whether these two images. So for example, if there are three images, we can do some we can ask that whether two images are similar, 1 2 are similar. Not we are directly taking that labeling from for each images like 1 2 3. We are not taking that labeling from them. So basically we are trying to send some kind of age, okay, that whether 1 2 for this triangle, actually whether 1 and 2, these two images are similar or not. Okay, so in this way age query can be done. Age query can be done, but there are something that in age query, suppose for example, these two images, these are two spaces. So there can be the option that same spaces or not same spaces. Okay, so this can be different thing. Here, three images are outsourced and there are 4 options, 5 options. You need to choose that options over there. Now it is too expensive if we do this kind of things, that we need to outsource all these possible edges. So if that number of n be the number of images, so n C2, so it's order of n square. So it becomes very difficult to outsource these images and get the opinion from them. So there are some techniques that is available in this paper, actually, Vinayak paper. So right now, what we are interested, we are trying to find, suppose we are outsourcing these images, like for this example, I want to share it, that there are some images where we ambiguously, we generated this kind of difficult image where these are some actors who turned as singer sometimes after some years, it or she turned into maybe in other professional life. So if it is asked that whether Angelina Jolie and maybe Brad Pitt or Leonardo DiCaprio, how I can group these images, and we outsource these images so that dual characteristics will be there. So basically dual characteristics are present here, and we fix the number of clusters. Here in this problem, we fix the number of clusters, that if there are 3 clusters, you need to get the clustering from this crowd work. So in that case, we get this kind of opinion. So for example, this is one kind of opinion, that these 3 are basically same image, same cluster. These are basically in same cluster. These are basically in same cluster. So if we get multiple opinions from this crowd worker, then our objective is how I can find this consensus opinion, that what should be the final clustering. So here there can be different method. The first problem is that level correspondence. Someone can put it as 1, someone can put it as 2. So level correspondence is the first one. I need to make some standardization based on some reference solution, and then I will give the final answer based on this level correspondence. We need to make some standardization. And finally, we use some kind of method that is a Markov chain-based model, where we need to understand that which transition. So for example, some objects, this is one object, and this is, suppose there are 1 2 3 4 5 6 7 8 9 9 objects are there, and that crowd opinions are collected from them, that please put your opinion which cluster should be for each of these objects. So here basically we are getting that first 3 objects in same cluster, then 4 5 6 in another cluster, 5 7 8 6 7 8, okay, 7 8 9, these are in another cluster. But we are trying to, after standardization, we can tell that how many times is one is going to be transition, okay, is going to be changed into another level 2 or another level 3. So in that way, we can understand that which worker is good or which worker is bad. So in that way, we need to find that weight, and then a Markov chain-based modeling is used over there. And finally, we start with a transition. We get a transition matrix from there, and finally, we start from a stationary distribution, because you see that object can be in each of these object can be in fast. I mean, for each of these object, there can be three possibilities: first cluster, second cluster, and third cluster. After this algorithm, we want to find that maximum distribution, that in which cluster it should belong. And then in that way, question-wise, we should consider this situation, and then we will perform this analysis. So we did this kind of experiment over there. So this is the, that opinion structure over there, and this is the clustering solution. And we actually compared those things with some of this ensemble method, where we need to put that each time you see that this problem has this method has some problem, because we fix that clustering number of clusters. So that is a drawback. So right now, because you see that CSPA, HGPA, MCLA, this kind of ensemble method, it takes that input number of clusters every time. And here, that's why you see this number of images are less in our case. So we also tested that method for different real-life dataset where that number of objects are higher, maybe 150 or 200, because I can't put a large set of images, because crowd workers are not interested to put their clustering solution for a large set of images. So that is the problem. So how I can choose best number of images, maybe k equal to 3, number of clusters. What can be the number of clusters, probable number of clusters we can tell. And finally, there can be another situation where we did not mention that what should be the number of clusters. You people, you crowd, you can decide that which is the number of clusters. So it generates a difficult problem, because we don't know that ground truth cluster. What should be that ground truth clustering is not available for this type of task. Here, basically, these are some kind of players of different countries, but there can be some categorization, because they although they are in different countries, but in some, if we consider that positions, in which positions they are playing, some are midfielders, some are playing as a forward. So in that way, we can categorize, we can cluster. Even maybe they are from different countries, but they are playing in the same club. So how I can cluster those kind of ambiguous images, and directly we did not put this kind of image, rather we distort so that people cannot compare this from internet, just directly copy and pasting and then getting this answer. So it is also prohibited. And then finally, we are trying to get some clustering solutions where some partial clustering can happen. Partial clustering solution means in previous work we have decided that everyone will give the answer for each of these objects. But right now we are feeling that yes, that can happen, that everyone will not do that clustering. Rather, some parts are given, some objects we are getting, it is going to be clustered. But after getting this response, how I can aggregate this decision? So that is the main problem we are considering right now. But there is a problem. Sometimes it may happen that for difficult images, people will not respond. If we impose this kind of constraint that yes, you don't need to choose all these objects, you don't need to cluster all these objects. For some cases, for some difficult questions, we can't get that answer from any crowd work. So these are the different challenges we are facing. And also in screen, actually in monitor, when people are seeing, so it's very interesting that how many objects I should put over there. Maybe it will be 5 or 10. There are some papers, they are using some 20 images, and out of 20 images, they can do some kind of clustering, but it's not mandatory that all the images you should cluster. So how I can get this kind of options, and what should be the final answer for difficult question? How many crowd workers I need to invest? How I need to outsource? So in that case, this is also a challenge. So in this situation, for example, I'll just take, I think that I'm running out of time, so I'll close now, just giving some notions that if I get two clustering solutions in this way, So it can be seen that two crowd workers are giving this, but here I can see this clustering solution for variable length. I mean that where that number of clusters is not defined. People can choose their number of clusters, maybe 5, someone can choose 2, someone can choose 4. But here I can tell that if the number of clusters is high and still these two objects are in same cluster. So that means this clustering, these two objects are, their bonding is too high. So in that way, we can make some co-association between these objects. Co-association means how much time these objects are getting clustered with other objects. So if there are n objects, so n cross n will be the matrix where this value will tell you that how many times different clustering solutions are putting them into same cluster. So this is the co-association. But right now, you see, if the number of clusters becomes high from a particular clustering solution, I mean that from a particular crowd worker's perspective, so in that case, we can tell, yes, it should be separated. If there are 100 objects, if there are 100 clusters, each object should be separated and they will be in single cluster. But if it happens that 99 number of clusters and still two objects are in same cluster, so in that case we can tell that yes, their bonding is too high. Their confidence is too high. So in that way we can utilize this information to find out the final answer. So I think that we are running out of time. So I'll conclude this. So these are the some of these important things that I tried to mention, that selection of perfect crowd worker, depending upon the hardness of the question, might be another direction of research in the field of crowdsourced clustering. Another thing, we have some kind of constraint. So in addition to, I mean, that dependent judgment analysis, that we can outsource this clustering problem with taking these options twice. But there's a challenge that it makes budget higher. So it will be cost consuming. So how I can make the trade-off that maybe all these questions will not take, rather some partial questions for some objects, some not all objects, rather for some objects, specific objects that may be difficult, we can take the repeated opinion, and from there we can utilize that dependent judgment framework where that confidence of crowd worker can play, and how I can get that solution from this crowd worker. So that's the thing. These are some kind of some references, and I should acknowledge some of my great collaborators along with these crowd contributors and some funding agencies that helped me a lot to travel in different places. And thank you so much. So please, thank you for your patience, and please tell me if you have any queries, any discussions, and some, I mean that problems that we are facing, some solutions.
Mm-hmm. Thank you for a great talk. I think it's time for a great discussion. Do you have questions in the audience right now? Let me check the chat. The chat contains only the time stamp message, which is fine. But so while the audience is heating up, I propose to start the discussion. My first question is, when you are explaining the crowdsourced clustering problem, what is the interface of your task? Because usually, well, you showed the pairwise example in the very beginning of your talk when you said that, like, are these items similar or not, something like that. But then you showed 3 figures with the cluster assignment. I think there were cluster assignment.
Yeah. So the thing is that, so the thing is that this was basically the state of that approaches. Here, we did not perform these things. We generally, this is the thing. This is for Vinayak papers. They are basically, they are utilizing this querying edges that pairwise they are outsourcing this problem to crowd and get some information from them. But in our case, we are basically putting some kind of images. We are testing that, yes, 3 images, then 5 images, then 7 images, then 9 images, if we get that information. So that's why it is like that. if we, yeah, so this is image over here where we can put that 5 images, and we mentioned that there will be 3 number of clusters. There will be 3 number of clusters. So you should group this in this way. So for example, Leonardo DiCaprio is own this Oscar. So in that case, he can group these things. But sometimes it may feel that yes, in most of the times those two actors were in same film. So they are the co-actors. So that's why they put this. But in another perspective, some crowd workers put this as female and this as male, and this is on a separate cluster. So that's the thing. That's a different perspective from where we can get the response. We basically machine cannot understand this kind of perspective, that context actually.
So people's opinions diverge because of different backgrounds, different opinions, so
Yeah.
subjective reasons indeed. And in my opinion, the second option is more reasonable.
Yeah. But the thing is that if we get that information, so, okay. So for example, in India, actually there are some cricketers, and he turned as politician after retirement. So maybe that after 40, they turned as a politician. So it's very difficult right now that to recognize him that he's turned a good politician. But how people will recognize whether as a cricketer or as a politician? So if that the kind of dual characteristics will be there, so how we can tackle this problem? How machine can understand? So that's the thing, and we try to distort that kind of images so that people cannot directly get that response from that internet. So that's why we are trying to make some interfaces and then get the opinion from crowd. But the drawback here, basically, it is fixed. But the problem becomes more difficult if it is, I mean, that the number of cluster is also varying. I don't know that actual number of clusters. And also that ground truth is also not available. So that's the problem. So basically what we do, we have a set of crowd opinions and we don't know that actual ground truth. So what can be the answer for that? We can compare that whole set of crowd opinion and that aggregated answer. We can consider these two things, whether these two are matching. All set of opinion, we are comparing this clustering solution with all of these clustering solutions with this metric like adjusted rank index. They basically compare the quality of, I mean, that agreement between two clustering solutions. If it is one, so that means these two are similar, otherwise they are dissimilar. So if I can find an aggregated clustering solution, then those are much more close to all of these solutions. So that is good, that we are getting some, at least some good consensus.
How is it annotated? What is the interface here? So is it the one you showed maybe a few slides before, or it's a different interface?
Yeah. We for example, we make some Google form over there, and we put some kind of images. In some cases, we are trying to develop some website, and there we can utilize something. So this is the interface. But we'll try, for example, here some calculations can be, we can do some kind of calculations that if we put some kind of constraint over there, that for example, in this case, for example, basically, if we put this is the paper of this Vinayak was basically, you cannot put these things, that some constraint is there. If you tell that yes, 1, 2 is similar, then we cannot tell that 1, 3 is similar, because it means automatically 2, 3 is similar. So these are the some constant that if you give some kind of 1, 2, then also these are not permitted. These are not permitted. You cannot put that 1, 2 is similar and simultaneously 1, 3 are similar, because that means this 1, 2 and 1, 3. So that means it is not good. I mean that it is some kind of dependency is there, some associations is there. But here, basically, you can tell that yes, out of 3 images, 1, 2 are similar. So it's like query of these edges are basically outsourced to that crowd.
Yeah, and
so basically this is the like LLM. I mean that either these 3 will be there or LLM. Basically this L is for any for particular, this is matching, this is not matching. So these are the different situations, but these are permitted. But I can't tell that this is the permissible options.
Uh-huh. And then you and is it also what? Yeah, that's the interface I mentioned. So is this the interface used for clustering, or so it's like a complete graph of objects,
Uh,
or
yeah. For example, when we, for example, I skipped it part because till that time I paused. So the thing is that here, for example, if I get, for example, that you were talking that it's a graph. Yes. If you get some kind of similarity that out of two objects, I mean that among these two objects, how many times they are appearing in the same cluster. So I can make a co-association matrix. Maybe that adjacency matrix we can get from that. So that can be a graph. And what we did, basically, we don't know the actual number of clusters because this is the next problem that I was discussing, that where we varied the number of clusters. We don't know what is the actual number of clusters. So that's why we leave this to crowd that, yes, you can choose the number of clusters. So basically what we did, after getting this similarity matrix, we fixed a threshold value. You know that, I mean that there will be some edges from each of these node are basically these objects, not crowd workers. These are the objects, and their adjacency means, I mean, their association means how many times they are appearing in a same cluster. So if I fix a threshold value and if I delete based on some threshold value and transform this similarity matrix into an adjacency matrix depending on this threshold value. Basically, if this value is greater than this threshold, that will be 1. Otherwise, this age will be 0. So we can get some adjacency matrix from that similarity matrix. I mean, similarity matrix has some value that two objects are in same cluster, how many times they are occurring, how many times co-occurring, I mean the co-occurrence of these objects in the same cluster. But right now, after choosing some threshold, we can make a similarity matrix to a adjacency matrix because at that moment, based on this threshold value, we can put either it is 1 or otherwise it is 0. If it is greater than this threshold value, it is 1, otherwise it is 0. So in that case, we have this graph right now, that adjacency matrix, and then we compute the number of connected components, strongly connected components. So this way we can get some clusters, some estimation that yes, if I move this threshold value, right now this same thing will happen repeatedly. Okay, we'll delete again some edges. So if I choose this threshold value, that means we are deleting some edges. We are deleting some edges based on this threshold value, and then we are getting some adjacency matrix each time, every time after deletion. And then we are seeing that yes, some number of, we are observing the number of connected component each time. So this number of connected component is basically the number of clusters actually. Because you see those clusters are strongly connected, those number of objects are strongly connected, so that means they are in a group. So if, for example, if we measure the stability, that how much time even after deletion of edges, how much time they are in same cluster, this you see that here basically for 3 number of cluster, although I am deleting so many edges, those objects are remaining in same cluster. So that means that cluster 3 is more stable. So in that way, we can make some standard solutions that yes, it may be that this number of cluster will not be like this 12 or 13, rather it will be close to 3 or 4. We cannot directly tell, but at least we can understand yes, for 3 or 4, that number of cluster will happen. So that is the thing. But there should be some theoretical justification. We have tried and we get some proof, but I think that we can do something more on that. There are some scopes over there.
Yeah, do we have maybe more questions from the audience? Because I can talk about this a lot of time. So yeah, let's.
Yeah, no issues.
Yeah. So more questions, please.
Hello, thank you for your report. My question is follows. What do you think about applications of clustering via crowdsourcing? When it's better than machine learning clustering algorithms? When do we need clustering via crowdsourcing? Because I do the same tasks, and it's interesting for me to know what do you think about it.
Yeah, thanks for your question. So the thing is that first I mean that while I was describing this whole thing, I described that there can be some context. There can be some context based on which machine can't understand that exact context, what people can think. For example, if someone plays, he can have some dual characteristics. So in that case, machine, some example, for example, we use that ID data set where some designated features are there like sepal length, petal length, this kind of things. But everyone knows based on this, we can categorize, we can do some kind of clustering. But the problem here is that if some hidden characters are there, something you mix some, we don't know the exact context that how people, I mean that, for example, in India, as I told that there can be some players who played after 40 years, after 40 years, he played so well and he is recognized as a good cricketer. But right now, after retirement, he turned into politics. So right now, if someone, if I need to group those images, like those people who turned in a different profession, turned into different professions. So in that case, how I can categorize whether I should tell him as a cricketer or maybe as politician. So that kind of things we cannot do. I mean that you just using, because you see that people can think, some people can think, yeah, he is more recognized as cricketer, so he can put in as cricketer. Someone can put as a politician. Maybe he thinks that yeah, he's according to his statistics, it is not so good. Rather than there are some good cricketer over there, and he is much more successful as a politician. So that can be the thing, and there may be some interesting that some kind of fuzziness will be there. Someone can tell that yes, 40% he is a cricketer and 60% he is a politician. So that kind of difficult task, and when you get these things from multiple clustering solutions, I mean that multiple crowd workers, how I can make some consensus, because that crowd workers can be spammer, he can do some kind of malfunction. So there can be different situations. That's why I mentioned that maybe we can frame it as a dependent judgment framework. I mean that we can solve this problem, collecting those responses. Maybe there are some too hard questions that people are not interested to do some kind of clustering over there. So in that case, how many extra opinion we should take? So that can be the different direction where we can work.
Thank you for the response. Do you have more questions? Okay, no questions so far. I think I have maybe one last question. And so this approach, which is based on connected components, and you mentioned that you use strongly connected components. I wonder,
yeah,
how did you obtain the directed graph here? So as soon as you use strongly connected components, what marks here?
Yeah, basically we did some kind of, as I mentioned that, yeah, from this crowdsourced opinion, basically if I get this kind of options, that is a crowdsourcing. After crowdsourcing, we are doing some kind of level correspondence. Here you see someone can put as 1, but this 2 and 1, these are not standardized, na? Because someone can put this as 1, someone can put this as 2. It is not defined, right? Because I can tell, I can label by according to myself that if I put that at 1 object or 1, and I can put that this object as 4 in different clusters, maybe 5th object as 3 in a different cluster, but it is not mentioned over there that leveling. So I can put some kind of level correspondence to make the standardization that now after level correspondence, I can tell these 2 and these 2 are same. So after that, we do some kind of, we make a co-association matrix or similarity matrix, that how many times, so similarity matrix between these objects. So it will be like 5 cross 5 matrix, where we can tell that how many times this item 1 and item 2 are occurring together, in how many times, from crowd workers 1, crowd workers 2, crowd workers 3. So suppose out of 10 answers, I am saying that in 2 or 3 answers, they are in same cluster. So we can make some association over there that out of 10, 30, I mean 3 by 10, it will be, if 3 times they are appearing in same cluster, so it will be 3 by 10. But in that way, we can make that similarity matrix, and then we can set a fixed threshold value, and we can decrease that threshold value one get with a very small amount. So for example, in this case that I was trying to show you, that first we need a weighted similarity matrix by taking the weighted voting approach and taking down the ranking of this clustering solution. Okay, we'll take that, consider that which clustering solution is good or which is not good. Maybe some clustering solution is very bad. We can compare this using adjusted random index. So after that, we can fix the threshold value and we can delete some edges based on this threshold value. That means we can choose, suppose 0.5 as threshold value. Those edges will be removed which have less than value, I mean, which have less value than 0.5, which is greater value than 0.5, we will keep. And then we will find that connected component. So some objects which has less association with them, among them. So in that case, they will be in separate clusters. So every time we'll delete some edges, we'll increase the threshold value, and then the number of cluster will high. Number of cluster will high because it will be like that. At the end, there will be no edges because all edges are removed. So the number of cluster will become high, and then we should study what is the stability of a particular cluster. So in that way, basically, we can do the, weighted graph and then that cluster.
Yeah, thank you very much for this comment. Okay, great. Do you have more questions from the attendees?
Thank you so much.
I think yeah, you can write questions in the chat if you cannot ask them using your microphone, but I think yeah, and Sujoy, could you please go to the references? I just want to remind this paper from 2016, I think. Yeah, it's from 2016 that you mentioned. In the middle of your talk, I think.
Yeah, Vinay paper is not there actually, so I mentioned over there. So there are a lot of papers.
It's V was the first letter of the after
yeah.
sorry, I can't remember the entire string.
Yeah, I think yes, R Vinayak.
It's Vinayak. Yeah. Okay.
Yeah. Yes, 16th paper. Yeah.
Okay, so if we have more questions, let me check. I see none. All right, I'm really grateful for you for this talk. It was super insightful, and the topic is actually super intriguing. I believe clustering is a task that's super great at trying to extract structure to find out relationships between objects and so on. And so far, unfortunately, crowdsourcing studies do not spend too many attention to this actually. And I believe this talk will be useful as a milestone or as a starting point for more research in this very, very challenging problem.
Yeah, there are so many challenges also. We are trying to explore these things that I told you, that difficulty, how we can utilize more techniques or develop some techniques for difficult part. That if I want to outsource all these questions, all these images in a particular screen, and it is sometimes difficult to get the response from crowd. They are not interested to give all these opinions. But that problem, if we give some partial question, maybe that hard or difficult question will not be answered. So how we can do this kind of thing? So there are many challenges we can solve.
Mm-hmm. Okay, so I believe we can conclude the seminar for today. Thank you very much again for a great talk.
Thank you so much. Thank you so much for inviting me, and very nice to. Yeah.
Great. So have a nice day, and